What's going on, kids? Today we're going to take a look at cutting rotors on our Ammco benchtop brake lathe. So a quick tour of this machine. Up top we've got some adapters here for different sizes of rotors and drums. We're just going to use these as a spacer. We'll only need one of them because we have a 3-jaw chuck on the bottom that we're going to use. But we've got a vibration damper that's going to help us get a better finish on our rotor. And then we've got this reverse thread nut with a shoulder on it, and we mount the rotor to the machine. We need to make sure we put that shoulder side in so that it actually gets tight and holds on to kind of rotor assembly that we're going to build on the end of the machine. We've also got our vibration dampers that are going to go around the rotor, and we've also got some extra cutters here, which we'll talk about in a second. Down low, we've got our different backing plates depending on what size rotor we're cutting. And we've got our 3-jaw chuck that we're going to use to actually mount the rotor. Got a double-sided open-end wrench for making any adjustments to the machine. And as for the machine itself, we've got our power switch and a fuse reset. And kind of working from right to left, we have our adjustment knob to move our cutter kind of in and out between our 2 cutting jaws. So we would open up this set screw and spin the knob, and as we rotate this clockwise and counterclockwise, it's going to move our kind of rotor assembly right and left. We've also got a feed rate knob here. That's for cutting drums, but we don't need to worry about that for right now. The back of the machine, here's our feed rate knob for cutting rotors. So if I lift up on this handle and pull towards me, I set that to a fast pass, and that's going to be all of our rough cuts. Or I can lift up and push away from me, and that's going to set it to a slow pass for our finish cut. We've got these belts back here because it's belt driven, and you'll see me kind of reach back here and pinch as I go to tighten the rotor assembly onto the machine. That's how we can tighten everything up without the machine turning over. As far as the cutting side, we've got a knob here that brings our cutters in and out. And that's where we're going to bring it in to start our cut. And then as I set the feed rate, it's going to spin this knob kind of automatically and start bringing those cutters out along the face of our rotor. So cutters themselves, to bring those in and out, we've got these knobs on the back. There's also a shoulder on here that we're going to be able to spin to zero this out once we touch off the cutters. And the cutters themselves are triangular. So we've got 3 cutters on this side, and I can remove this flathead screw and flip the cutter over and then screw it back down. And we're actually going to do that before we start our cuts because all 3 sides here are smoked. We can see they've been used. So we'll flip it over, and there should be 3 fresh sides to cut with on the other side of this cutter. But before we actually start cutting, let's look up our specs and see how much material we can remove while we're trying to get rid of the runout issue on these rotors. So we're here on Identifix. We've been here before. I've already plugged in our vehicle information in 2016 GMC Canyon SLT with a 3.6 liter V6. And we're going to go down to our quick hits area under specs, and we're going to go back to our brake specifications. This is the same place we went to on the measurement video. And this is all the information we need, not only for cutting our rotors, but also for putting all this stuff back together. Our brake caliper torque is on here, so when I go to put this back together, I need to mount my caliper to the hub at 133 pound-feet. GM uses coarse thread bolts, so the torque spec is crazy, crazy high to make sure they don't come out. And a lot of their cars, they ask for Loctite blue or some sort of thread locker to make sure they don't back out on you, because that is a very, very bad day when your caliper bracket bolts come out on you. It ends up usually with a broken wheel and a flat tire on the side of the road. So 133 pound-feet for that, and then discard thickness is what we really want to look for when we're cutting rotors. We need to make sure that once we've shaved down enough material off of each side of this rotor to get it smooth, get it flat, get rid of any parallelism, any runout issues, or any thickness variation issues, we need to make sure that when we're done, we're still above 0.98 of an inch. Again, nominal thickness is our 1.07. That's what this rotor was when it was brand new. We measured this in the measurement video, and the overall thickness for this rotor was 1.066, if I remember correctly. So it's still pretty close to brand new, but it's certainly not going to be there once we're done cutting. So on the top of the toolbox, I've got my rotor, and we need to prep this thing before we can put it on the brake lathe. And if we look on the inside of our rotor hat, we've got kind of a nasty, rusty surface. So I'm just gonna take a rotary air tool with a paint stripper or rust stripping brush on it. It's kind of like a hard sponge. And just run this around the inside surface here to break up any loose rust. That way the rotor is gonna be able to sit flat on these adapter plates, which we'll get to in a second. So that's cleaned up, and now we need to figure out which one of these adapter plates we're going to use to put this rotor onto the machine. There's 4 different sizes of these. They're all located underneath the machine. I've got the 3 larger ones here. Let's start out with the smallest one that we've got, and these are going to go inside the hat of the rotor with this dimpled side facing in. And this one goes in, but it kind of slops around. This is the largest one that we have, and it's just barely too big. It's not going to go in there. So we need to find our Goldilocks backing plate. This one goes in, pretty much perfect. There's almost no slop. And now we can start putting this rotor on the machine. To mount the rotor to the machine, we're going to start by using our backing plate. When we slide the backing plate down, we need to make sure that this cup side is out, facing this way, because that cup is going to provide a relief for the jaws that are kind of sticking out the backside of our rotor a little bit. Before we slide the rotor around, we need to make sure that these jaws are spun all the way out so that when we slide the rotor around, we don't slam into our cutters. This should slide on here relatively easily. It's a little gummed up right now for whatever reason. That's going to slide on. We're going to grab one of these adapters, these cone adapters that we saw earlier, and slide this one on first. And then we're going to use our vibration damper. This is the first of a couple different vibration dampers that we're going to use. You slide that onto here. And then this is that weird reverse thread nut with a sleeve on it. And that sleeve is going to go on first. The sleeve goes in first. Let's thread this on by hand. It's reverse thread. It always catches me off the first time. The reason it's reverse thread is so that when the machine is spinning, it doesn't back its way off and become loose. On the back side of the machine, we've got our belt drive. So to tighten this nut, I'm going to pinch the belt, use the wrench that's here on the machine already, and just snug this up a little bit. That's all we need. Now it's time to touch off the cutters to the surface of the rotor. So for my first cut, I'm going to spin this knob on the outside and run the cutter into about the middle of the rotor. And I'm just going to touch it off. So as I slowly run this cutter in, maybe you can see it kind of dance in the reflection where that cutter is not perfectly parallel with the rotor. So that's our runout issue. And as I bring this in, you may hear it kind of skip as it cuts. I'm going to do the same thing on the back side. And now I've set my zero. So I'm going to lock my cutters down. And I've got to come back to these back knobs. So right now I am nowhere near set to zero. So this inside collar here is going to spin
This outside knurled portion, that's what actually moves the cutters in and out. So I need to hold this one still while I spin this collar until I get to 0 with inches on the left. So I'm at the 0 lined up with this mark on the machine, 0 with inches on the left. This will also cut metric depths, so we're going to be using Freedom units here today. So we'll do the same thing on this side. I want to set this to 0 with inches on the left. 0 with inches on the left. So now I know where my 0 is, and I can crack my cutters free. Run this in until where I want to start my cut. I can actually back this off a little bit if I wanted to. Run this in to where I want to start my cut. Right about there looks good. We'll check both sides. That looks good. And run this back to my 0. And so for this first pass, I'm just going to take off a 2/1000 cut. I'm not going to go crazy because I want to see the runout issue that we have. So each tick mark on this is 2/1000 of an inch. So I'm going to move this cutter in to 2/1000. I'm going to move this cutter in 2/1000. Lock my cutter blades. Lock my cutters. And then back here we have our feed rate now. If I lift up on this and push away, it goes to slow. If I lift up on this and pull towards me, it goes to fast. Now, slow is going to be our finish cut, our final cut. That's going to give us our best, smoothest surface on the rotor. Fast is what we're going to use to hog off the most material so that we can get this rotor to be flat. So for these first couple passes, we are just going to do rough cuts or fast passes and take a look and see what this rotor looks like. All right, so I'm going to stop the machine, put that in the middle position to stop the actual feed, and then I'm going to flip the switch back here to turn it off, and we can run our cutters out of the way, and let's take a look at our rotor. Well, we don't really have the best finish on here. So if we look, our cutter was touching this top part, but not cutting the part over here. On the reverse side, we did not cut here, but we did cut down on the bottom. That's because this rotor has that runout issue. We measured our rotor runout to 0.0045 in the other video. This is that exact same rotor. We only took off 2/1000. That was nowhere near enough to get rid of our runout concern. So we're gonna have to do a couple more rough passes, fast passes on this rotor until we can get it so we have a nice, smooth, even finish all the way down. So this next pass, I'm going to go ahead and take 4/1000 off. So that's 2 tick marks on my dial. Lock my cutters. Start the cut. So the back side's looking better, but this front side still has some issues. We've cut down here, but we haven't cut up here, so it's time to take off some more material. All right, so we're finally there where it's cut both surfaces evenly, the whole surface on the inside and the outside. We've only done rough cuts so far, but I did have to do 3 passes to get rid of that one little stubborn spot on the outside. So that's why it's super important that you're going to measure your overall thickness when we're done to make sure we're still above that discard thickness. Again, for this rotor, the discard thickness is 0.98 of an inch. I've got my dial caliper on deck here. So we're going to do one last pass. This is going to be a finish cut. So I lift up and push forward on the knob to go to a slow pass. That's going to drag the cutters much slower along the surface of the rotor, and that's going to give us a better finish. It still does that record groove like we talked about with the Pro Cut. So when we're done, we will do a quick kind of scuff with a Scotch pad, clean everything down with brake clean before we put it back on the car. I'm going to take 3/1000ths off with this pass. So, as you can see, the cutters are moving much slower. This knob is just barely turning. But our surface finish is 1,000 times nicer. That's what we're used to seeing when we buy a brand new rotor, when we see one coming out of a box. It's that nice, almost mirrored finish. That's what we're looking for. All right, so now that our rotor is done cutting, we can see our surface finish is much better than it was before, certainly much better than it was with our rough cuts. And now we need to measure it to make sure we haven't taken off so much material that we are below our discard thickness. Again, our discard thickness was 0.98 of an inch. So I want to grab my dial caliper, take off our vibration damper, and measure on the outside edge of the rotor. Close that down, and I can close my clamp. And then take my measurement. So again, to read this, we have our whole units, or our tenths, and our full inches on the bottom scale here. And then I go to my needle for my hundredths and thousandths. So I am past the large 1. I am not quite to the next one over there, that 1/10. So I'm at 1.040 on this rotor. Still well above the 0.98 for my minimum thickness, but definitely below that nominal thickness of 1.07 that this rotor was when it was brand new. So this is ready to go back on the car. I need to put an omnidirectional finish on this with a Scotch pad, just kind of scrub this thing around. I would usually let it run on the machine and then just take a Scotch pad and brush gently up here to get rid of that record groove so that the brake pads don't sit in that and try and pull themselves out of the rotor. Put the truck back together, torque the caliper back to spec, put the wheel back on, torque the wheel to spec, pump the brakes before I drive it to make sure the pistons go out to take out the space that we removed from the rotor so that way I actually have a pedal before I back the truck out. Take it for a test drive and make sure that there's no vibrations or noise from the brakes, and we should be good to go.
Alright, so the truck's back together. I've got the brake torque to spec, I've got the wheel torque down to spec, I've pumped the pedal to make sure I still have a pedal feel, I've come back to the brake lathe and cleaned it up, put all the tools away, wiped down all the chips and gotten those down into the chip tray, and I think this job is done. If you have any questions, please feel free to shoot me an email. Be good, and I will see you next time.